Welcome back. This is Mr. Hassan's Maths channel. I'm now going to answer question number 9 from the January 2023 International A-Level Edexcel Pure Mathematics P3 paper. This question here is about this graph, and figure 3 shows a sketch of part of the curve C with the equation y equals the square root of 4 times e to the power of x squared, where x is greater than or equal to 0. And we got to, first of all, let's say find dy dx, giving your answer in simplest form. Okay, so the first thing we got to do is we've got to differentiate this expression. So before I start differentiating it, I'm going to write it in a more friendly way for differentiation. So I'm going to write it, I'm going to change it into index form from surd form. So I have 3 plus 4 e to the power of x squared to the power of a half. Remember, something, the square root of something is the same as that thing to the power of a half. Now, to differentiate this, I note that this is a function inside another function. In fact, inside another function. So you have this function inside the e to the power of x, which is inside the, this whole thing raised to the power of half. So when you have a function that's inside another function, for example, f of gx, we differentiate this by differentiating the main function first and keeping inside exactly how it was, and then multiplying by the differential of the function inside. That's called the chain rule. Okay, so here the main function here is something raised to the power of a half. Something raised to the power of a half. So to differentiate something raised to the power of a half, you multiply by the power and take one from the power. So dy dx will start off by a half times, and this stays exactly as it is at first, 3 plus 4 e to the power of x squared. Now you take one from the power, a half minus 1 is negative a half, and then you multiply by the differential of what's inside the function. Now what's inside the function is 3 plus 4 e to the power of x squared. Now if you differentiate 3, it becomes 0, it's a constant. If you differentiate 4e x to the power of 2, initially it just stays the same, because e to the power of something doesn't change when you differentiate it. It's one of the special properties of the natural number, e to the power of something. It stays the same. Okay, so e to the power of x will stay as e to the power of x. But however, this is e to the power of x squared. So you have another situation like this. You have a function inside the function. The main function this time is e to the power of something, which when you differentiate, it just stays the same. But then you have to multiply by the differential of what's inside the function. So the differential of x squared is 2x. So you got a half times 2x. So those cancel out. So we can say dy dx is going to be 4 times x times e to the power of x squared times this bracket, which is 3 plus 4 e to the power of x squared to the power of negative a half. So we can leave our answer like this. We can write the answer, if we want, as this in the denominator, this thing raised to the power of negative a half. So 4x e to the power of x squared divided by, and you can write 3 plus 4 e to the power of x squared, all to the power of a half. You could write this as square root or power of half as you wish, but that's fine. That's fine. We can leave the answer like this. That's fine. We can leave the answer like this. That's fine. We can even write the square root underneath of what's in the denominator, and that's also fine. So there's the answer to part A of this. So 9 part B, it says the point P with x coordinate alpha lies on C. So this is the curve C with the equation y equals the square root of 3 plus 4 e to the power of x squared. And the point P lies on this curve, and the x coordinate of point P is alpha. So the x coordinate of point P is alpha. So that is alpha. Okay. Now, it says, given that the tangent to C at P passes through the origin. So this line is the tangent to the curve C at P, and it passes through the origin. Okay, I'll call this line L. All right, as shown in figure 3. Show that x equals alpha is a solution to this equation here. This is the equation of the curve. I just put that there myself. But this is the equation that we have to show is a solution. Okay, that the x equals alpha is a solution to this equation. So this equation represents the solution to this equation is the place where the line and this curve touch, where there's an intersection between the line and the curve. Okay, so in order for us to find the intersection between two, functions, we have to solve their equations simultaneously, which we already have the equation of the curve. We need the equation of this straight line, L, the tangent. To find the equation of a straight line, we need two things. We need the equation of the line, so we need two things. One of the things we need is the gradient of that line, and the other thing we need is a point on the line. Now, we know that this passes through the origin, so that helps us a lot. If we use alpha and 3 plus 4e to the power of alpha squared, it's going to be complicated. We know it passes through the origin, so we know the equation of the line will be y equals, as we know, it's y equals mx plus c. In this case, c is 0, because the y-intercept is 0, so it's just going to be y equals mx. So we need the gradient of this line. Now, the gradient is going to be when x equals alpha, what dy dx is. So the gradient is equal to dy dx when x equals alpha. So when x equals alpha, you're going to have 4 times alpha e to the power of alpha squared over the square root of, that's to the power of half, so I'll just write it as a square root of 3 plus 4 times e to the power of alpha squared. Okay, so that is the gradient of this line, of this straight line. Okay, when x equals alpha. Now, so therefore the equation of line L is y equals all of this, 4 alpha e to the power of alpha squared over the square root of 3 plus 4 e to the power of alpha squared times x. Y equals mx plus c, c is 0. So that's the equation of the line L, and the equation of the curve C, as we were told, is the root of 3 plus 4 e to the power of x squared. So the square root of 3 plus 4 e to the power of x squared. Okay, so remember this is alpha and this is x. Now, where do they intersect? That should say y equals, sorry. Okay, where do they intersect? When we solve them simultaneously. So if I replace this y with what y is equal to, I'm left with the square root of 3 plus 4 e to the power of x squared is equal to 4 times alpha e to the power of alpha squared over the square root of 3 plus 4 e to the power of alpha squared times x. Okay, now, what we know is we got to show that this equation is a solution to the x equals alpha is a solution to this equation. So what we can do is we can say, okay, we know that x has to equal alpha, right? Because we see the equation here has got everything in terms of x, and here we have our alphas. So what I'm going to do is I'm going to replace the x with the alphas with x, because x equals alpha. We know that x equals alpha is the solution. So we got to show that hopefully then we'll end up with this expression or this equation. Okay, so what I'm going to do now is I'm going to, wherever I see the alpha, I'll replace it with x. So 3 plus 4 e to the power of x squared equals 4. Now, instead of alpha, I'll write x, e to the power of x squared times x over the square root of 3 plus 4 e to the power of x squared. Now, if I multiply both sides by the root of 3 plus 4 e to the power of x squared, these two will multiply, and they're exactly the same, except they're both under the square root. So the square root will now be just cancelled out. So 3 plus 4 e to the power of x squared equals, and this is 4x times x, which is 4x squared, and e to the power of x squared. Now we want to show that this is the equation, so this has to be positive. So what I'll do is I'll say this is equal to 4x squared e to the power of x squared minus 4e to the power of x squared minus 3. So we've shown that 4x squared e to the power of x squared minus 4e to the power of x squared minus 3 is equal to 0. Okay, so we have shown this relationship here, that when x equals alpha, this is the equation, okay, which solves the, finds where they intersect. So the point P, x equals alpha, is a solution to this equation. Okay, so we've shown that. And now for question 9, part C. And this is a question which is about proving that the roots of a equation lie between certain values, to do with numerical methods and iteration. So here it says, hence show that alpha, which is the solution to this equation, lies between 1 and 2. Okay, so what we do is when we want to show that alpha lies, or root lies between certain values, the first thing we do is we rewrite this equation. We say let's call it f of x equals 4x squared times e to the power of x squared minus 4e to the power of x squared minus 3. And then we say, let's substitute f, we put one of the values into this expression here. So we have 4 times 1 squared times e to the power of 1 minus 4e to the power of 1 minus 3, which gives you 4e minus 3, which is negative 3. So we can see that f1 is equal to negative 3. And when we substitute 2 into here, we have 4 times 2 squared, e to the power of 2 squared minus 4 times e to the power of 2 squared minus 3, which gives you, that's 4 times 4, which is 16, e to the power of 4 minus, and here you're going to have 4 times e to the power of 4 minus 3, and that gives you 12 e to the power of 4 minus 3, which we can write down its value. Of course, it looks like it's going to be positive, of course, so we've shown that it's positive. I'm going to put down its actual value. So 12 times e to the power of 4 minus 3. The 3 is over here. That gives you 652 to 3SF. That's 652. So we can see that when you put F1, you get negative 3. When you put F2, you get positive 652. Okay, so we can see that between F1 and F2, so when between in the interval between x equals 1 and 2, in the interval between x equals 1 and x equals 2, there is a change of sign in the function. Okay, in the function f of x, which we called f of x, in f of x, and we should also state that f of x is a continuous function. It doesn't have any breaks in it. It's a continuous function, therefore a root must lie between x equals 1 and x equals 2. Okay, so in this question, you must write down a reason. You can't just leave it, in terms of what we've written here. We can't just leave f1 equals minus 3, f2 equals 652. We can't leave it like that. We have to mention that between x equals 1 and x equals 2, there is a change in sign. So you must mention the change in sign. And you also must mention that the f of x is a continuous function. Those are the two phrases that they're looking for you to get the mark for this question. So one of the marks is to show the actual arithmetic change in sign, and the other mark is to state these 2 points. That's the other, those are what they're looking for to get the mark for this question. If you look at the examiner's report, it's very clear. They want to see both these things mentioned, change of sign and continuous function, as well as the calculations which lead us to the fact that there's a change in sign. It's very important that we have an understanding of that, what we have to do here in this type of question. Otherwise, we don't get these 2 marks. All right, so part D, it says, show that the equation in part B, which is this one here, can be written in this form: x equals a half times the square root of 4 plus 3 e to the power of minus x squared. So one of these x's has been made the subject of this formula. And obviously, because you have a square root here, it must be this x in the one that's written as x squared, that has been made the subject of the formula. So we have to make that x the subject of the formula. So the first thing I'm going to do is I'll have 4x squared times e to the power of x squared minus 4e to the power of x squared minus 3 equals 0. So the first thing I'll do is add all of this to both sides. So I have 4x squared e to the power of x squared is equal to 4e to the power of x squared plus 3. And then I'm going to divide by 4 times e to the power of x squared both sides. So I have x squared equals, I'll have 4e to the power of x squared plus 3 over 4e to the power of x squared. Okay, so now what I'm going to do is I want to rewrite it in this form. So we can see we have two separate terms here. So I'm going to split this up into two separate terms as well. So this is going to give me 4e to the power of x squared over 4e to the power of x squared plus 3 over 4. And what I'll do is I'll write this e to the power of x squared on the numerator. So I'm going to have 3 over 4 e to the power of minus x squared, because that it will start off as this 3 over 4 e to the power of x squared. I'm going to write this in the numerator. That's all. Okay, with the negative power. We know that 1 over x to the power of n is the same as x to the power of negative n. We're using that principle of indices. So now this gives me 1. These cancel out. And I have 3 over 4 e to the power of minus x squared. Now, we want to put it in this form. Okay, so what I'm going to do is I'm going to express these with the same denominator first. So I have x squared equals, now this is going to be 4 over 4 plus 3 over 4 e to the power of minus x squared. And then I'm going to take out a quarter as a common factor. So I have x squared equals a quarter times 4 plus 3 e to the power of minus x squared. So now I don't have any fraction left inside that bracket, which is exactly how we have it here. There's no fractions there. And then we can see that if we take the square root of both sides, you have x equals the square root of all of this. So the square root of a quarter is a half, and the square root of all of this, which will be 4 plus 3 e to the power of minus x squared. And there's our answer. That's what we had to show. Okay, ran out of space a little bit, but it's important for you to show the steps very clearly. Okay, so I've done that here. So first of all, we made the x squared the subject, and then we had to manipulate it algebraically so it came out looking exactly how we're supposed to show it looking. So I decided that, okay, we're going to split up into two terms, so we split up into two terms. Okay, then we have to get rid of the fraction inside this bracket, you could say. So I made the denominators the same and took out the common factor, which is a quarter. And then when you take the square root of both sides, this becomes a quarter. The quarter becomes a half, and times the square root of all of this, which is what we have there. All right, so there's part D. That says the iteration formula. This is 9 part C. The 9 part E, sorry, says the iteration formula, okay, which is what we just, rearranged to make it look like. Xn plus 1 equals a half times the square root of 4 plus 3 e to the power of minus xn squared, with x1 equals 1 is used to find an approximation for alpha. So this will help us find an approximate value for the roots of that equation that we had earlier. So it says, use the iteration formula to find for 4 decimal places the value of x3. So one of the things that you'll notice it mentions in the mark scheme is, first of all, we have x1. x1 is equal to 1. Now x2, now what I would suggest is you actually put down your steps for x2. So you actually put the fact that you're putting 4 plus 3 e to the power of minus 1 squared. Okay, minus 1 squared. So this 1 is not, the minus is not part of the square here. So you be careful about that. Okay, so when you set this up in your calculator, what I would suggest you do is this. This is how you use iteration. Okay, so we want the first value we put in to be 1. So the first thing you do when you set up something like this for iteration is you press 1 and you press equals. Now that's the answer inside your calculator now. If you type answer, the value there will be 1. So then you set this up here. So you have a half, and then you have times the square root of. You have 4 plus 3e to the power of minus, and then you press answer squared. So in the first instance, when we have 1 in our answer as our answer, this is going to give you exactly the same as what this is supposed to be. So you press equals here, and it will give you the value for x2. Okay, it gives you the value for x2. Okay, which is 1.1294. I'll write it to more decimal places than I need. So 1.12956. So 1.129516. 29561, sorry. 561, like that. So I'm going to write this step down. Then we want to find x3. So x3, what we should do is then we need to press now. This is now our answer. This is now our answer. And what we have to do now is we have to put this back inside this formula. To find x3, I take this value and put it back where it says xn. Okay, so in this case, it will be xn plus 2, right? And xn plus 1 now, right? So we're going to put this back into here. All right, and we'll find the value is. Now, all I have to do now, because I've set it up like this, all I have to do is press equals now, because now the way it's set up, it's going to put back into here whatever the answer that came out was, which is exactly what I want. So when I press equals again, it's going to give me x3 directly, which is 1.099719. 1.099719. Let's make sure I've written it down correctly. 099719. It goes on, but we want it to 4 decimal places. So that's 1.0997. That's x3. Okay. Now they want us to find alpha. That means we basically the more we keep going, the closer and closer we're going to get to the actual root. Now in the mark scheme, it mentions to get the full method mark for this, what we need to do is we need to take this value and put it back into the iteration formula until we find that our answer settles down. So what I'm going to do, I'm going to write down all the values for x4, x5, x6 until we end up with something that's settled to 4 decimal places. Okay, so what I'm going to do is I'm going to press equals again, and that will be x4. That will take this x3 value, put it back into there. That gives you 1.1062. So 1.10625. 1.1062. I'll put 84 just to give it some extra. 1.106286. Sorry, 86. Then I'll do the same thing for x5. Okay, I'll just press equals again, and I'll write the answer I get down. That's 1.10480. 10480. Okay, then I'll do the same for x6. I'll just press equals again. That gives you 1.10512. Okay, and then I'll do x7. Which equals again 1.10505. 0550. 1.1050504. Continues on like that. So it looks like we're getting close to the answer. It's going to settle down. It looks like it's going to be 1.105 something, probably 0. Let's press it again and see what we get. Yeah. So you have 1.10506, 1.10506. So almost there. I think that should be enough. The next one. Yeah, that's it. So it's 1.10506 continues. So we can see here that the value of alpha is 1.1051. Okay, and this is to 4 decimal places. Okay, so use the iteration formula to find to 4 decimal places the value of x3 and alpha. Okay, so there's the answer to 4 decimal places. Right, we can see that that's what it settled down to. Now, this question doesn't ask us, I think that's the end of the question as well. Yeah. So this question does not ask us to justify that this is a root, okay, to 4 decimal places. It just says find it to 4 decimal places. So the mark scheme mentions writing down each of the intermediate values until you get to where it settled down. So we can see that, you know, around here it starts settling down. Even if I wrote, I guess, for x8, it settles down to this value to rounding to 4 decimal places. Okay, now, sometimes the question says, and justify that this is a root to 4 decimal places. And justify that this is a root to 4 decimal places. So in that case, I'm going to show you how to deal with that in case it comes up in another question, right? So although it's not part of this question, you don't have to do it for this question. I'm going to explain that in case you do get a question that requires you to understand that. So if they say justify, just imagine I put part F, justify. Okay, then to justify, what we'll do is we will take this value of alpha and we will write it as 1.105, and then we'll take the upper bound of this, which would be 1.5, and we'll take the lower bound of this, which would be 1.10505. That's the upper and lower bounds. We'll take the upper bound and the lower bound. Okay. Now, we will substitute that back into the original equation. Not in this equation, the original equation, which is this equation over here. Okay, we'll substitute back into this equation here. So we take the equation that we had from before, and we write it as f of x equals, just as we did before, you have 4x squared e to the power of x squared minus 4 e to the power of x squared minus 3. That's f of x. So just like we did before, we put in the upper bound and the lower bound, and we see that hopefully there's a change in sign. We put that into here, and we put 1.10505 into here, and we see that there'll be a change in sign. So we have 4 times 1.10515, and that squared times e to the power of, we have 1.10515, and that squared, okay, e to the power of x squared, minus, we put the space first, then minus 4 times e to the power of 1.10515, and that again is squared, and then spaced and minus 3, and that gives us 3.1755 times 10 to the power of minus 3. 3.1755 times 10 to the power of minus 3. Okay, so that's a positive value. And then when we hopefully change those, all those there, we go back to this and change this to make this as delete, make this as 0, to make it, instead of 1505 at the end there, we do the same here. And then we do the same here. Okay, we see we get a negative value. So that was negative, what was it? Negative 4.861. (86131) times 10 to the power negative 3. So we can see there's a change in sign. That means the root must lie between these two values. Okay, so then we would say as there is a change in sign, and it is a continuous function, therefore there is a root in the interval, okay, between 1.10515 and 1.10505, somewhere between those two. Okay, it's best to write the other way around. Low one first. 1.10505 and 1.10515. Okay, now, again, this is a part that I've made up. This is not part of the question, just in case you get a question similar. Now, why would this be considered as a root? Why would this be considered as a root? It will be considered as a root because supposing this is 1.10505 and this is 1.10515. Somewhere between these two, there's a root. So as you can see, before it was positive, then it was negative. So somewhere between these two, there's a root. At this point, it was positive. By this point, it was negative. So somewhere between them, it's crossed over. The curve has crossed over the x-axis somewhere between these two values. Because if this is the x-axis, this is the y-axis, at this point, it had a positive value. At this point, it has a negative value. So somewhere between them, there must be a root that lies. Now, everywhere between these 2 points, if you round this to 4 decimal places, if I round anything higher than this and lower than this, anything just below this, like if it was like this, anything, this value and anything above it, and this value and anything below it, or not this value actually, anything just below this value, when you round it, it's going to round to 1.1051, which is, the value we have to justify that's equal to 4 decimal places. So we take the upper and lower bound of this, we put the values of that inside the original function, okay, what we're saying the thing is a root for, and then we see that there's a change in sign. That proves that between these two values, the root must lie, and anything between these two values, any number between this value and that value, when you round it to 4 decimal places, it will give you this as your answer. That's how you can justify something is a root to a certain number of decimal places. As I said, this part F is not part of our question, but it's a very common question that does come up in this topic. That's why I have decided to just give you that extra little bit of explanation for that in case you get a question like that. All right, so that concludes question number 9 from January 2023. Other questions from this particular paper can be found in the playlist that will be posted over here. Other questions from these topics of, I guess we had differentiation and we had numerical methods, can be found in these playlists, and you can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.